Question 6. Sketch the graph of y equals tan x for the domain negative pi less than equal to x less than equal to 3 pi on 2. We're back to normal things. Y equals tan, and we're using an x. So there's definitely nothing to be scared about here. Again, this domain just means we need to sketch between negative pi and 3 pi on 2. Let's do it. Where should we put our y-axis? Well, we're not significantly using more negatives than positive. This is like 1.5 pi. This is just pi. So we can put the y-axis in the middle. And with tan, it has some height to it. So I like to go 1, 2, 3, 4, and have our x-axis there, and then 1, 2, 3, 4. And then we won't actually use the 4. We'll go a little bit past it in case we want to mark the 4 there. But with the previous ones, we've just been doing 1 there. So we'll probably just only need to mark in the 1 and the negative 1. All right, x-axis, straightest line I've ever done in my life. Oh, it started off really good. And then it, got a bit average after that. Just like with every trig function, interesting things happen at the quarters of the rotation. So we can think hard about it and go like, okay, I only need to use 3 pi on 2 for this side of it. I only need to use pi over there. This one's bigger, so I could just put a 3 pi on 2 here. That probably would work. At least, unlike the last one, these are similar things. Like pi on 2 does fit nicely into pi. And so it won't be like the last question where one of them is as a pi on 3 and one of them is a pi on 2. It's gonna get a bit gross. However, I would still recommend, let's just make this 2 pi. And let's make this negative 2 pi. Because this is almost 2 pi itself anyway. So we're not gonna like waste. Can you guys see my quotation marks? We're not gonna waste a lot of room here. And it just simplifies. It's just more what we're used to, right? And so because it's not going to waste a lot of room, I'd rather just standardize. Find that halfway point there, roughly. Okay, so this one's pi, negative pi. And then interesting things happen at the quarters. So we're also going to do a pi on 2. Obviously, when I say quarters, I mean quarter of a full rotation. So pi on 2 pi, 3 pi on 2, 2 pi. First quarter, second quarter, third quarter, fourth quarter. All right, negative pi on 2. Negative 3 pi on 2. Okay. Tan. What is tan of 0? When the angle is 0, we're right here. How steep are we? 0. We're not steep at all. So tan of 0 is 0. When we go, again, we have a positive and a negative domain. So we're going to just do the positives first, then come back and do the negatives. So looking ahead to this first quarter rotation, how steep are we? We're infinitely steep. So it's undefined there. So we're going to have an asymptote here. Let's think about what happens. Like there's no point we can mark. So let's just think about what happens on the way there. We're going to be increasing in steepness. And around here, our gradient is equally across and equally up because we have that pi on 4, the 45-degree angle. So our gradient's going to be 1. So it helps to go halfway here and go to the 1 and put that. Okay. And after that, we just keep increasing, right? So we need to start here. Don't go straight to it. Try and curve underneath it a little bit. I kind of went straight anyway. I'm sitting at an awkward angle because of the way the camera's set up. So don't judge me. Something like that is good enough. Then we go up there and that's it. Obviously it'll go up to like, it'll start to approach infinity and etc. Here, as we come down the other side, we're going to have a very steep but negative gradient because as we go across, we go down. So very steep, which means we're down here, but it's negative. Sorry. So very steep meaning it's either going to be here or here, but we know it's down here because it's negative. Okay, and then to help us draw the curve and get the get the curve right, around this halfway point, we're going to have a equally across and equally down. It's going to be 1 because it went down. It's going to be -1. So halfway, -1. So we need to come from down here, hit there, and when I say hit, I mean miss completely. So you can kind of rub that one out. I think my rubber will not work on this. It might just make it worse. Yeah. Oh, good enough. Because this point doesn't really matter, it's fine to just rub it out. Unless your teacher has told you that they are marking on those points, then obviously you should then add them in. But a lot of the time we just want to see these key points like this and see the rough curve. So we just draw that in lightly to help us draw the curve, but it doesn't actually matter. All right, and then we get to pi, and obviously we're flat again. So back to 0. After this, same behavior. Remember, tan repeats itself already because it's about the gradient is one way to think about it. And the gradient is like the line there is the same gradient as this line here. So we're just going to repeat ourselves. So halfway, we're going to hit 1. Also, we need to check in. Do we need to keep going? Yes. So pi is within 3 pi on 2. And the next key thing is going to be at 3 pi on 2. So we should keep going. We're not going to have to like stop short of it. We can just safely go all the way. So I'm going to mark in this asymptote here to help us draw it. It needs to go all the way down as well. Even though we're not going to use the down part, it still needs to be marked in. Okay, let's try and hit this. Something like that. And then keep going and slope upwards. And then now we are definitely at 3 pi on 2. And so we don't need to keep going here and do that. But again, we do want to mark this asymptote. We want to mark the whole line. Don't just stop halfway. Cool, that's that done. Now, negative pi. We just go the other way and we go until we hit negative pi. Negative angles, so we're going this way. And so we're going to have negative gradients. And then we're going to keep it negative, more steep, more steep, more steep, more steep until we're down here and it's infinitely steep or undefined. And they're all negative. I'm not sure if I said that. So yeah, negative. So we're going to be coming down this way. Around here, we're going to hit that -1. And we're going to have an asymptote here. Yep. And nice little slope to get to there. And then keep that slope going to get to there. Nice. Keep going because we have to go all the way up to negative pi. And so what happens after that? So now I'm going to draw a fresh one. That's getting gross. Pull it down a little bit. We should have room here. So we started here. We got down to here. As we go across here, we're very steep at first. And we're positive because as we go from left to right, we go up. So we have to go up from here and come down to hit there. Halfway, we're going to hit a 1. So let's try and aim for that. Oh, that has to be the best one today. That's beautiful. Okay, yeah, and obviously we end up with 0 there because as we get to a rotation of, oh man, this is getting so crowded. Negative pi goes that way. And so we are here and we are flat. So 0 gradient. So that's why we hit there. Okay, negative pi up to 0, up to 3 pi on 2. Looks good. That's done.